until this time of our competitions. And now, moving on to our last track of today. And that will be circular economy and waste management. Our next team presenting will be TextRe from Israel. And they will present their idea on a textile to polymer recycling system that eliminates textile waste and reduces carbon emissions by 80% high, and they will be presenting online, ladies and gentlemen. So, can we just go ahead and check for the connections and see if they are ready? Hi, Miss Lee Cohen.
Can you hear me?
Yes, we can hear you. Let's give a round of applause to welcome Miss Lee Cohen from Israel, connected by the Hi, can you hear us?
I can hear you well. Can you hear me well?
Yes, we can hear you very well. All right, so it is now your time to present your innovation to us to Net Zero Challenge 2025. Please go ahead.
Thank you. Firstly, apologies for not attending in person. I just gave birth and still cannot fly to Vietnam, but I'm really looking forward to arriving soon. So even though I'm not here with you in a room, but in Israel, I want to ask you to take a moment and look around you, or think of the products you own back home. Have you ever stopped to think what they are made of? Now take a look on your clothes, or even touch them. Have you ever stopped to think what those are made of, or what really happens to them when you stop wearing them? And what if I tell you that your old t-shirt may turn to be your next headphone cover? And no, it's not a gimmick. It's a viable alternative for rigid plastics. Hi, I'm Lee Cohen. I'm the co-founder and CEO of TextRe, and we bridge the gap between two industries facing the shared need for carbon reduction. We have plastics all around us. Yes, even in our clothes. And even though recycling becomes inevitable, the use in recycled materials is still very far from the norm. The reason? Lacking pragmatic, scalable, and cost-effective solutions. That leads to an increased need for additional feedstock to answer market demand. It's growing and growing. Our initial target market is the rPET, as being the most recycled polymer in the plastic industry, and is going to be in significant shortage due to bottle-to-bottle regulation. That creates for us market opportunity of over $11 billion. Surprisingly, PET is also the most common material in our clothing, and overlooked resource. Today, basic waste is being landfill, turning the fast with no efficient recycling solution as a major producer for textile today. For circularity and management waste, we convert mixed synthetic textile waste into valuable and sustainable engineered materials that can be used in various plastic applications. Our patent-pending mechanical process uses the inner properties of textile fiber into synthetic one and convert it into the same properties and performance that the plastic materials need. All that with overcoming the feedstock variance, which is the main barrier today for textile recycling. Compared to alternatives in the market, TextRe comes forward and offering our customers holistic solution, pragmatic, scalable, and cost-effective alternative for seamless transition from using virgin polymers based on fossil fuels into sustainable ones. All that with no compromise on performance nor price, and with dramatically carbon reduction of over 80%. Our team is a combination of deep experience and knowledge within our relevant industries: chemistry, textile, plastics, and injection molding. We have accomplished already 2 successful pilots in Israel with potential design partners and industry aligned, and we validated our material can be really implemented in existing lines. Now we are having 9 more pilots, mainly in the automotive industry. The proposed project will utilize large scale of textile in Vietnam with our partner Garment & Co. As a pilot, we will use 5 tons of its waste and turning it into over 10 tons only in the pilot of our polymers produced by our second partner, Canepa, all in Vietnam, of course. The pilot will also showcase our double impact company outreach. Firstly, we prevent textile lining, and secondly, we are reducing the amount of lying on virgin polymers in the plastic industry, but rather on the sustainable one. Additionally, we showcase 25 and deliver 25% saving to our customers as our products are the same in performance and cost as virgin one and industry standards and are ready for direct integration into existing production lines. That means very low capex. The pilot budget is 500K and is matched between our partners in Vietnam. The budget will be divided between manpower, equipment, and operation. In 12-month project, we intend to set up a small plant in Vietnam to utilize the waste of our partners and produce the material, and be ready for scale and start sales in 2027 in initial market segments. We are also currently fundraising, and we're also looking for strategic partners to scale, and really hope and look forward to this opportunity in Vietnam, as I mentioned, many producer of textile and many producer also of plastics. Combination of our two activities. Thank you so much. And again, I wish I was there physically.
Thank you very much, Mr. Cohen. You can still hear us, right?
Of course, I'm here. I hear you very well.
Yes, okay, that's awesome. I know there was a bit of network issue on our end, but I hope that you still follow through with your presentations. And right now,
I do.
Yes, okay, so let's go ahead with our Q&A from our judges, yes? And first up, Mr. Klein, please.
Can you hear me? See?
Yes, I can hear you well.
Okay, the question is, you say there's a cost saving of 20%. Is there a volume that you need to get to get to that cost saving? Would you offer that whole cost saving of 20% to your customer, and at that cost saving, what is your gross profit margin?
The cost saving is not related to the volumes we are utilizing. The cost saving is due to the fact that if our customers have the transition from the virgin polymers that we are using, we can save them because it's the same transition. We have the same profit, the same performance, the same cost as virgin lines, so by having the transition and not need new capex or new industrial lines, that we can save them money. What was the second question?
At that cost saving for your customer, what is your gross margin?
About 40%.
So you basically create a product that will promise you a 20% gross margin, at the same time, it's still 20% cheaper than the alternative in the market.
Yeah.
And that was the end of your questions, Mr. Klein. Any more to?
Oh,
okay, thank you very much. And let's hear it from our next judge, Ms. Patricia Lee, please.
Hi, thanks so much for your presentation. So I understand that there are some challenges specific to material recycling, textile recycling, right? Maybe what I would like to understand is, how do you envision scaling growth by being able to secure high quality feedstock? And there would be different, I guess, mixed variability of the input. So how is it that you are able to ensure the consistency of the output if you do not, or I mean, what variation would it take for your technology?
So I understand the question. Maybe firstly, we need to differ between chemical recycling, fiber to fiber, which is textile that goes to the fiber, then they need very high purity of the material. The innovation in our process is we are going from textile to product, meaning that we have some agility about the feedstock and the output we have. When we are saying that we overcome the variance in the feedstock, meaning that we have the range of variance that we can handle. It doesn't mean that we don't care at all what the feedstock is, meaning that we have a lot of agility and the way to play. So what we are doing today, we are taking feedstocks that we know how to utilize. So if today we are utilizing, for example, 90% of polyester, and we don't care what the other 10% are, our R&D focuses on increasing that range. So we want to achieve feedstock that maybe contains 60% polyester or PA. This is the polymer that we are mainly utilizing, and be agility about the other percent. The way that we are ensuring how the material, how the output is uniform, is internal QA, meaning that we are entering our feedstock and we have, it's part of our patent. In the mechanical process, we know how to differ the variance, and then we have some additive, it's part of the formulation, that we can overcome some properties that we don't want in the textile, we do want in the plastics. It's important to say that anytime that we are dealing with waste, we have some variance and we need to overcome the feedstock. But this is the reason that we are doing textile to products, because there we can have some freedom to operate about the properties of the plastic rather than the textile. The combination between the two allows that freedom of operation between the properties, because if you have synthetic fibers that have strength in a certain amount, it's not exactly what the plastic needs, and this is how we can apply it to each other. I answered the question?
Yeah.
Yes, and that was our last questions from our judges to you. Thank you very much, Ms. Lee Cohen.
Thank you so much.
Yes, thank you. A round of applause. Thank you for joining us online, and we hope that we can welcome you here at Net Zero Challenge.
I wish.
Yes, okay.
All right.
Thank you very much. Thank you. Okay. All right, and that was the presentation of TextRe from Israel. And right now, without any further ado, let's go ahead and continue with our next group from Vietnam.